Should even write to the console,
Yeah.
right? Okay, cool. That's a good place to be.
What are we running?
The last one.
I don't remember it.
It's on the wall.
Oh, there it is. There it is. Cool.
Okay. Well, we're all done. Easy. Yeah. That's good actually.
Oh, yes, always.
Can you like go to the
There's another
You got a laptop? Sorry. Oh, you've got experience.
Stand on my bag, it's fine.
It's yours.
It's not clean.
Which environment do you use? Do you have any?
We need Windows.
We've got a virtual box installed.
Yeah.
Actually get a Vagrant.
How much you're going to get out?
We should set up Vagrant for the
You're welcome to throw any insights into the go along. Appreciate
was coming down.
Maybe you guys can.
Very close.
Based on what you did last week, I can get anywhere.
Hey, I would give value.
It's useful for you to be able to talk about.
You don't even not give value.
It's useful for you as a dev manager to be able to not
That's
bullshit
good.
away for TDD sessions.
Wow. Yeah, I know how to do
Well, find something
Find
that's
something
similar
with
to
it,
that.
yeah.
Yeah, there we go.
C sharp.
The one he decided wants to do yesterday, like he was okay, so he wants to basically write and build the whole of
Welcome, guys.
in one.
Thank you all for attending this session. Who's done TDD before? A little bit. Who's done more than a little bit? Okay, so this session is always just a little bit. Yeah, I like that.
A little bit at a time.
Yeah. All right. So this session really is about, you know, how do you get started in TDD. So if you feel like you've got a handle on it, you've been doing it for a long time, you might not get that much value out of it. We would like you to stay for a bit of a discussion at the beginning because you can add some insights. But other than that, feel free to move somewhere else if you find you're not getting value out of it. So my name is Janco. This is Mark. We work at a company that is now officially called Driven Alliance. It used to be called Driven Software. We do coaching in teams at all levels, so technical, team, organizational, all of those kinds of things. We like to help developers with some practices that we believe make them more productive and happier in general. So that's what we do. Today we're going to talk about, how do you get started with TDD? I don't know. People keep talking about TDD. This is such an awesome thing. We can get value out of it, and I don't know how to start. I found that an incredibly hard thing a couple of years ago when I started. So hopefully, we can get you past that point of fear today. So yes. So I want to ask you a question, and you've got post-its on your tables and some markers, and I would like you all to grab a post-it or two and write on there what is important for you when you're coding. And I know it's a broad question, and it's intentionally broad. What's important for you when you're writing code? What are you looking out for? What makes you feel like you're achieving something, you're moving forward? One per person. And you...
As you write them, I'll come and collect them and read them as we're going. So as you write it down, just get it. One thing. Okay, so I got green bar. That's one of the items. Rapid feedback.
How do you like to feel when you're writing code? What makes you feel like you're making progress?
It works. Okay, there's a whole bunch. Beauty, quality, value, and performance. Is that right?
I've got making code work. Oops. Quality.
Easy to
Yeah.
code, always have working code. Value again. This must be an agile code. Talking about value all the time. Where's the value? Let's go. There we go. Okay.
You got it.
This is clearly an agile conference. People used to writing stickies.
Fast
Yeah, I
feedback.
get this.
Deliberate change. Tests pass. Understanding the problem.
I've got fun. Who wrote this? Awesome. Love it. Got quality again. Sure, a lot of quality stuff.
Conceptual integrity. That's kind of deep.
Past requirements. Getting expected results. No errors. Simplicity. Forward momentum. Awesome. Any more? Anyone got anything there? Okay, awesome. Now, the next question from that is, let's leave that out for now. How do you get all of those things? So I'm seeing a lot of quality, I'm seeing momentum, I'm seeing there was feedback at some point, simplicity is something about design, there's value, understanding the problem, what else is there? Green bar, so passes requirements. How do you get those things? The people that have been doing TDD, you don't have to answer it this way. So people that haven't been doing TDD, how do you get that? And I'm not trying to catch you out, I'm trying to understand how are you currently fulfilling these things if you're not doing it. Anyway.
How do you know if you are doing TDD?
How do you know?
How do you know if you are doing TDD?
How do you know if you are doing TDD? You'll know if you're doing TDD.
It's really hard, right? So you start, like when you're doing TDD and you're trying to achieve that stuff, it's a different type of thinking that you're applying to how you're writing code.
So no one intentionally writes bad code. No one intentionally wants to do a bad job. The question then is, if these are the qualities and the values that we aspire to, how do we get that just from normal coding, writing code one line after the other every day? How do you get quick feedback? Do you start up the entire system if you're working on a big system to test every small change that you make? How do you know that it's not breaking something anywhere else? All of those kinds of things. So that comes back to feedback. I think we should stand up and run around. People are a bit slow after lunch.
Command bar or control F5.
Oh, is that okay? Yes.
Visual Studio.
Oh.
Shift F.
Alright. So, who believes that TDD can give them these things? Okay. Why?
So can I add to it? Who's getting those things from TDD right now? It's interesting that it's not as many hands as people believe it.
Sorry,
So, how are you getting that from TDD at the moment? It's from your experiences.
Feedback.
Rapid feedback. How are you getting
So
rapid
it's
feedback?
the single most important thing I've found is minimal friction in terms of whatever system you have in place. The tools you use to give you that feedback doesn't require that you have to do as little as possible. As soon as you get a tool set that it's like you've got to chop and change, do a whole lot of things, you tend not to do them. It's just giving you this feedback all the time. As you're coding, then you just get into the zone and it just works. And it's fantastic.
I guess my thing is, I hope you misunderstood the problem, so now you're writing tests to make sure that you don't understand the problem. Do you know what I'm saying?
Say that again, you write a test
You
to
write
make
a
sure.
test to basically make sure that you don't understand the problem, because you've misunderstood it. You think you're trying to get a particular value out, So you write a test to check if that value comes out, and then you write the code to make sure the value comes out, but actually it's wrong. So that's why I think like there must be more to TDD than just simply writing a unit test.
So, yeah.
For me, it's a safety net. So you've got a big code base and you've got thousands of tests. If you go and change something, you run out of tests and everything passes. You know, they're pretty sure that what you've written is good. So
Or you're pretty sure that what you've written didn't break anything else.
if you don't have any tests, you don't know.
You're pretty sure that what you thought you were supposed to do, you did.
But the reality is that whether you're doing TDD or not doing TDD, you're at risk of that anyway. You're at risk of misunderstanding a requirement, of building the wrong thing. You know, I think TDD isn't a solution to that particular problem. I think it's not a silver bullet by any means. But it turns out that for me personally, it's a workflow that I find makes my experience pleasant, and I believe makes for better code and a better structured system. Other people differ on that opinion, so.
Yes, and
But supposed to be at the end by now.
well, it definitely validates what you think you're doing.
Yeah.
Is correct. Where the verification process of acceptance test, it's not really can do it TDD, but you know, I think it's more than validation.
So one of the interesting comments that came out of one of the code retreats retros a year or so back, one of the guys stood up and when he was asked what had surprised him, his comment was he was surprised at how rapidly TDD zone you in on the problem and the key architectural questions. And I think that's the thing is by thinking about the problem and you're actually less likely to make the mistake of building the wrong test. So it's not the trivial test. It's not that I've got a method called foo. Test does foo return A. You know, you're thinking at a bigger level.
Unless you code Ruby.
I like that because it's not just about the test; it's about the design.
Yeah.
So that's hopefully something we can get into a little bit later today. Is this notion that people say TDD really stands for test-driven design, not development, and hopefully we can bring that out a little bit later today. Show you how that happens. So, who came here with an expectation to learn something? Okay. What do you want to learn?
How to apply it.
How to apply it? Okay. You want to learn how to apply it?
I want to know what makes it so great, because if you're so focused on the tests themselves, be sure that you're going to design modular, scalable code, rather than, for example, designing the code beforehand and then you define the test afterwards. You test in that respect.
Okay, you
So I'm
want
trying
to
to
see
understand why
the
you think
benefit
it's so great.
versus writing it first versus writing it
Yeah.
after. Okay. Okay. Cool.
I guess with everything, there's patterns and anti-patterns, and there's a right way and a wrong way. So that's kind of what I'm interested in is, when you're writing these tests, what are you thinking about in terms of maintainability, repeatability, extensibility, all of those kinds of things. So what I'm thinking about, I guess you could very easily get trapped in, I don't know, test for this and not this and not that, and then the next thing I've got this unmaintainable mess. So that's what I want to know.
Okay, good. Anything else?
So I'm interested in actually learning from all of these guys who have questions about TDD because I've been doing it for so long that I'm starting to question whether I'm thinking critically anymore about it. So I'm interested in hearing why you guys are going, hey, it doesn't make sense, because it makes perfect sense to me. But I want to know, well, why are you guys not doing it? Because there's reasons, and those reasons are actually really valuable in improving myself and how I do it, and how I talk about it.
Okay. Yes.
So just maybe on that, I don't understand. So we sort of within our project, we still in a sort of phase we built some code and now we've said, well, we kind of tried to get some speed and we left out a lot of our testing. So now doing the paints, and now we're trying to actually do this almost like a little bit like a year into like coding. So we've written some tests and stuff, but not sufficiently to give us any sort of way to really regress what we've done. So we can't confidently say whatever changes we made haven't broken other stuff. So we're trying to get to that stage. But like, and just sort of from a conceptual perspective, is it like, do you have to write the tests first, I think? Because I mean that's almost what I'm feeling from the union. Or is it just like a sort of tool that or mechanism that you can use to say, well, I've written some code and I want to test that it behaves in a certain way, and somewhere down the line, if the code is changed, does it still hold true, type of thing. So did it break anything? Did it change the behavior of something? So is it more like a tool that you use to just sort of check what you've written is still sort of doing what it's supposed to do? Or is it like a principle thing we're saying, okay, you have to try to test first and these are your reasons for it? So just from that perspective.
So the way I like to think about it is kind of like, part of the scientific method says, how do you prove something? How do you come up with a new theory or anything like that? The first thing is you put together a hypothesis, saying I believe this thing is true, and now I'm going out to prove it. Either disprove it or prove it. That's kind of like how TDD works. So you're saying, this is what I would like to get out of it. Now I go and write the code to prove that I can do it or I can't do it. So in that sense, if you approach it from that angle, you kind of have to do it in that way. So make explicit what are you expecting to happen if you write this code. So TDD is not going to help you retrospectively. So then it's test after development. So, and it's a useful discussion to have today. I think maybe we will make space at the end to have those kinds of discussions.
But also, so I mean, if that is like the actual sort of principle, then also like how you actually sort of adopt that approach. Because sometimes like you think about like a test, you might have, you don't exactly know how this method's supposed to work. You don't exactly know what the signatures or what the parameters are, and you might not know what the internal dependencies are, what you have to mark, what you not mark, those type of things. So how do you build almost your test without sort of really having written that code and knowing exactly what the dependencies are, what code needs to make, those type of things. So that's sort of something I'd like to.
Okay, so you're really speaking to the design part. If we say test-driven design, that's really what you're getting at there. And I think hopefully that'll come through a little bit later. Cool. So who's heard of the Dreyfus model of skills acquisition? So a couple of people in the room. So today, so just for the people who don't know, so it's a model. It's not necessarily right. It's just useful. And this guy Dreyfus said, people go through 5 stages when they acquire a new skill. It's you get novice, then it's advanced beginner, then you have competent, you have a proficient, and then you get to expert. So what's important at the novice stage is that it's just a repetition of something you see. So you don't think about why you're doing it or how you're doing it necessarily. It's just about repetition, and you're building it in, and all the while you're internalizing. Until the point where you get to expert, you've progressed through all of the stages, and you get to expert and you don't think about these things anymore. And the rules don't even apply to you anymore, because you figured out exactly how everything fits in, and you kind of make these gut decisions. So today we're going to really focus on that novice part where you can say, have a look at what Mark's doing or what I'm doing, and just follow along, and just get into that flow. So we want you to get a feeling of how to actually do this. So we're going to sort of lead you through it and say, just follow along. So what environments, languages do we have? I heard previously there was PHP, C, C#, anything else? Java maybe? Java? Python, cool, okay, cool. So if you have your environment set up to run tests, that's cool. If you don't, we'll make a plan. So you can all do console write lines, right? So that's good enough. We'll do that. Cool. So Mark's going to take us through an exercise, and you guys can follow along. So over to you.
Okay. So one of the things I find really useful in kind of getting started with, well, first of all, maybe a quick story about my exposure to TDD. I sat and watched somebody do a demo of TDD a couple of years ago. It looked awesome, amazing, and I sat there for 6 months trying to figure out how to write my first text. And I just couldn't figure it out. And kind of put the whole concept of TDD on the back burner. And eventually got exposed to it again and just made that plunge into what's the first thing I want to write as a test and try and figure out where I'm going from there. And one of the patterns I've noticed with me learning in TDD is sometimes you just have to get dirty. Like you just got to try it. And with time, you kind of refine that process. So we use katas as a great way to put you in a staged environment which is optimal for learning certain things. And we're going to do a kata in this first session called the string calculator kata. Has anybody done that kata before? Okay, good. So you guys, there's not going to be anything new here in terms of the kata, but the kata is really just a medium for the practice. And I'm hoping that you're going to share some insights in it. For those guys, just get your environments open. I've got Visual Studio open right here. I'm going to do things in C#. If the language doesn't make sense, if it seems foreign, we can kind of talk about the semantics. Go from there. And let me just open up the problem. So the string calculator kata, I know it from Roy Oshrov, who wrote a book called The Art of Unit Testing. It's been a number of years since he wrote that book, but that was kind of the first introduction I had to unit testing, and then on his blog he kind of put this kata together, which was a step-by-step problem that kind of led you into the process of a TDD cycle. So if we talk about TDD, you'll often see different patterns for it, but the one that's most common is you write a test. So when you write a test, you don't have any implementation for it, so it's a failing test. You do the quickest thing to get that test to pass, and then you go into that refactoring phase. How do we now make the code and the test appear easier to read, better structure, etc., etc. And then you just rinse and repeat. So we're going to go through the string calculator kata, and there are a number of steps. We're just going to start off with step 1. So step 1 says create a simple string calculator with a method that takes a string and returns a number. One other thing before I go into that is there are some very strong opinions on what's an appropriate way to start. So I've, Robert C. Martin or Uncle Bob will say that, you know, if your solution doesn't compile, that's a failing step. Other people say, well, you know, I just write the test and see where I go. So I want you to get straight up front with TDD. There's a lot of controversy on what is a correct TDD style and what's not. I think with time you get to almost like a pragmatic level where it works for you. In this case, I'm just going to look at the problem, and we want to create a method that takes a string and returns a number. And the example that they've given here is the add method, passing an empty string, and they're saying it returns 0. So that's the first case we've got in the kata that we're going to do. Okay.
So just what is the point of a string calculator?
So, okay, thanks. The purpose of the string calculator, let me actually kind of walk you through the different samples. It kind of builds up on if you had a string with a set of numbers in it, how would we add those numbers together? And as you go through the different steps, the things that you can do with that string gets more and more complex. So initially it's just like an empty string returns 0, then it's like a single number returns an integer of that number, until eventually you get down to kind of the last couple of steps where you can specify custom delimiters, and it's going to recognize these patterns and return the sum of the numbers in that string. Does that make sense? Like, I'm actually not too worried about the problem right now, because I just want you to get used to the cycle that we go through. So step number 1. String returns 0. So this is one of the first things I do when I start off with my test, is I'm trying to think of what's the first test case I want. What's the simplest step that's going to add value for me moving deeper into the problem. And like I said, with the string calculator kata, this is stage. They're kind of guiding you in this tour into this problem. I've just named this empty string return 0. We can refactor that at a later stage if we're not happy with that name, but it's just a starting point. It's almost like a place where I can get my mind going. I'm going to need a calculator. So I'm going to say, in my mind, I'm going to need some sort of string calculator class that I'm going to work with, and that's a design decision I'm making, deciding that this thing's going to exist. And you'll notice that in this case, that class hasn't been created yet. So I'm writing the test first. I'm assuming that there's an implementation somewhere. I haven't actually written this implementation so far. I'm using Refactor in Visual Studio, so it's telling me that the IDE is identifying that this class doesn't even exist at all. And I'm just going to new it up and make an instance of it. So that for me is an example, like a really small example of that red-green stage. I wrote a test, it was in a failing state. I then want to get the test to pass, so I new up the class and now the test will compile. And compilation can be seen as your test is not passing. Okay, so that's fine. I'm then going to go calculate .add, not the other one. And in this case, something like that. And I'll do it like this just to make it a little more easier. I'm just going to call the add method on my calculator class, passing through an empty string, and I'm going to make some sort of an assertion on what that result is. Now you see, again, I don't have this add method there. So I can make a decision right now. Let me go and just make sure that that add method is there for now, and I'm going to do that. So that my code will build again, and then I'll make some sort of assertion. Okay.
So if you don't have a test runner or a test framework at this point, you can just like write out to the console, you know, your expected result or the result you're getting back in 0 or whatever, just to compare them. Something like that. Just need a way to get that feedback.
So I want you guys to get to this point. Just start going. As soon as you're done, just kind of make eye contact. We'll pick it up. If you're getting stuck getting started, we'll kind of buzz around and make sure that you can get there.
The reason you guys prefer using a circle of that instead of a circle of
It's
equal?
purely syntactical. Like, that's my preference.
No, I'm just interested in why.
So in this case, what I like is I like almost like a fluent reading.
Okay, so I hear that, but the thing is that the output in that case isn't as obvious. Because all it's going to do is say it's failed, it's not going to say expected this, got that.
Yeah.
It would actually. It will.
So,
Yeah.
so we can run it and have a look at it.
Okay.
But this is just like a preference in how. This is n-unit. So this is the n-unit fluent syntax. Okay, just start again.
Do you, you didn't prefix your test case with the name of the method you're calling, is that how you normally do it? Because you're calling the add method and...
Yeah, okay, so that's a great question. Naming of test methods. Let's go into that while people are going. Like, I've gone through different derivatives of naming, and you'll see like some guys will have the arrange, act, assert, others will start every test method with test, should, or this should do that. And I've gone through different variations of that. I want my test name to be as short as possible without losing the intent. And that for me is the important thing. I find that having your test methods, like if you're in a team programming environment, just kind of get a convention in your team. But for me, it's just readability. So that's my focus.
So there's also this notion of coupling. So we know about coupling in code, and how tight coupling is bad and all of that. So if we were to bring in the name of the method into the test, that's a form of coupling right there. So what I'd rather like to see is saying, if I read that empty string returns 0, it tells me something about the functionality that I'm testing. It's not telling me something about the implementation as to how it's done. I don't need to know that an add method exists necessarily. I just know that, oh, this is kind of like a requirement. So this is some piece of functionality that I want my system to be able to do. And if I read that and the test passes, then I'm good with it. So what happens, so this is an expression, or the code's going to be an expression of my understanding of the problem as it is at this point in time. If later on I realize, oh, add is not a great name for the method, and I want to rename it, now I've got to go change all my tests that have the word add in it, things like that, because it's coupling at that level.
Okay. That's even worse. Are we comfortable? Carry on. Are we all at the same speed? Okay. So remember that red-green refactor, and you can hear this when you start with TDD. You can hear this time and time again. And it's just going to drive you nuts. Write the test. It's red. Get the test to pass. Get to the green state, and then refactor. What state are we in right now? I heard red. Why are we in red right now?
Because the add method throws an exception, so if you run the test, it will be red.
Okay, so let's just make that a little explicit for everybody. I run the test. So the code is compiling, and I know this sounds really stupid for people who have done this a lot. The code's compiling. The fact that it compiles doesn't mean that you're in a green state. It just means that you're one step closer to where you want to be. If I run this test, which I've just done right now, I'll see that the test method isn't passing yet. And if I go have a look, it's saying some sort of not implemented exceptions being thrown. If we look at the code, sure enough, we're getting that. Okay, we can see in the add method, not implemented exception is being thrown. What's the smallest step that I can do to get this into a green state?
This is where we expect high disagreement now.
Return 0. Okay, so it's very, very simple right now.
But I don't agree with that.
You don't agree with it? Give me an alternative.
So why not just write the code to make it do what it's supposed to do?
I want genuine disagreement. Is everybody happy that return 0 is the simplest step? Yeah. Okay.
But I think the point is that it's a valuable discussion as to why just do the simplest step and why not write the code.
Okay, so I like
it is a valid question.
Okay, so let's ask the question to the group. Why is it valuable to just do the simplest step here rather than carry on into the problem?
I think it solved everything. I mean, you know, there was only that one step, and I think trying to do more than that is adding like gold plating almost for that very first step. You know what I mean?
Okay.
So that very first step is complete now.
Okay.
I don't add much in that. It's also,
Anybody else want to add to that?
yeah, it goes,
So I'm very aware that I've got two guys here that have experience with this, and I want to spread it out to other people. It's a polite way of saying.
I don't know, for me, I think it's great if you're learning TDD to get into that habit of like writing, going in the smallest increments as possible, so that you, like you said, you don't end up gold plating and catering for too many other scenarios. But at the same time, I'm in two minds about it because it's like it's not a difficult step. It's not like a massive step that you're going to take. And you've also falsely made the test go green. It's not, you're not really doing what it says it is, but the test is green.
Why is it false green?
Because it's not testing whether the string's empty or not. So if you passed in a couple of numbers there, it's also going to return.
But in this case, okay.
See what I'm saying? It's like it's almost like false security.
So you're absolutely right. It is a falseness. It's a high degree of falsity here. The one of the reasons why we actually do it like that is we actually bullshit away at that moment, is that when you're laying out your test, you're actually laying out the API for your class. Right? So you're in the mode of thinking about what your class is going to look like from someone who will use your class. Okay. So you're not yet thinking about the deep innards of it. Right? You haven't yet even figured out what is the data structure, what private methods, what private variables do I need, etc. You haven't even gotten to that stage yet. So this is deliberately forces you to put a pause in the implementation thinking so you can focus on how the class will be used. You will offer this as a gift to someone else. Right? So what you do is that you just say suspend all thinking by bullshitting it. Okay. Then when you get your test to pass, it means that you're reasonably satisfied with that interface that's been laid out in there. That is, you're actually happy with calculator.add returns and int. You're satisfied with that. Once you get to that, which is when Mark will get to now, is that then you say, okay, I'm going to stop thinking about that on the top. Now let me think about how do I want to implement this. And then I'll switch to that, which becomes the next step, which is refactor. So in my experience, I can't think about both things at the same time.
so are you saying that you're really testing that you've got your implementation of that?
Maybe
The class is expected to do very high level.
You're oscillating between two things. Laying out the test is laying out an interface. Interface thinking.
Yeah.
Fulfilling that, to make it pass, when you use a refactor, actually implementation thinking. Can I flesh out this class so that it meets that interface? That's what it's about.
So on top of that, the other thing about it, what I find is that if you go ahead and implement the method completely, you're putting yourself at risk of writing a whole lot of code that is not covered by tests. And we're all at risk of this as developers. We like it. We sit there and we code away. And we go, oh, let's remember this. Oh, let's think about that. And suddenly you've got this whole bunch of code and now it's not tested. So this way you're keeping the discipline and you're building up that. And I think the way Aslan put it, I mean, it's also an aspect of documentation of the API. The tests now describe it for someone coming in cold. So this is what it does.
So let's give Mark a chance to get into refactoring that. Right?
I want to hear one more point from the gentleman.
It's actually more questions. So I mean, in terms of actually sort of following this type of approach, because you see, thinking about your API, right? But now I was wondering, because now you're going to get back to your point, you expect to be like working with functionality, and you're going to get all these false passing tests. At which stage do you then start to track, okay, which methods did I implement and which did I not? Because they're all just passing.
Okay, so there's one thing I want to clarify here. My understanding, this is not a false passing test. This test is passing, it's not covering other cases.
False implementation.
Yeah.
Yeah.
So this is not a complete implementation of the problem, but it's still a valid test in the fact that if I went here and I changed this to a 1, and I reran my tests, it would fail and say this is not lining up with the expectation you've seen. So there's a bit of discussion there, but let's carry on. Okay, so right now we're sitting at a green state, test is passing. what's the next step that we do?
Write another test to break
Write another test.
and make it go red.
Okay, for me there's a very, probably the most important step before we write the next step is the refactoring stage. And this is where you guys get to pull this code apart. Like, let's have a look here. What aren't we happy with here? And what do we look for when we're refactoring?
Here's a question. When you say refactoring, do we only refactor the code under test or the test code itself?
Okay, so I'm in this case, I'm worried about the test and the implementation. Like, that's an important thing for me from both sides. So what are we not happy with here?
Parameter name.
Okay, is that this one here?
Yeah.
Okay. Why are you not happy with that?
It has no meaning in terms of generally what the API is
Okay.
going to
So give me a better name.
Value. Yeah.
The hardest
Yeah,
question.
yeah. Value would work.
Value.
Value.
Okay. So we'll
Or,
do
yeah.
or. Sorry.
Added.
Added.
ADDEND.
ADDEND. Okay. Any other proposals?
Numbers.
Numbers to add.
Numbers.
Numbers. Okay. So I'm going to go with numbers. What is it moaning about?
Make it number. You never put number.
Numbers, number. Okay. So there are a number of directions. There are a number of places. Oh, wait. There are various options that we can go in this process. I'm going to go with numbers. I'm not sold on it, but I'm going to see where it leads me. And we're going to go from there. Anything else? Are we happy with this test? Anything else we want to change here?
You could use a constant for the empty string, but I don't know if that's...
Okay, we could use a constant for empty string. What would that give you?
Or what would they take away?
I think it would make it less immediate, the thing of what you're testing.
Well, if we did something like that, we do that. Same, do we gain anything from that? Do we lose anything from that? Does it make the test maybe a little more explicit? That really depends. I prefer the string.empty, but I'm going to go with this. Okay, are we happy that the first test, we're in a state that we can carry on? So this is the number one complaint I get about TDD. And that is, we've just spent like 10 minutes going over a really, really simple case. And there's this question about speed. Is this not slowing us down? Like, were these discussions a useful discussion, or was this just us over-reflecting on something that we don't really need to think that much about? Something I want you just to think about. We're going to talk about and then. Okay, so let's carry on. Single number returns that number. Does anybody want to drive me through what we want to name this method? Let's try a different type of naming convention for a test. What do you guys do for those that write tests?
So something interesting came up from you earlier when you said, well, that's a false, a false positive now. And sometimes I like to treat TDD as a notebook. So as you're doing these things and you realize, oh wait, it's actually kind of false, and there's something I need to make note of. There's an edge case here, or there's something else here. Make that your next text. So put that down as a concern, to be addressed. Mm-hmm. So it's a nice way to keep track and not worry about it right at that moment, but then be able to come back to it later.
So would you create a secondary test, like another test immediately before you reach the phase? Or
just put it in a comment or something like that, saying, oh, I need to make note of this. Then go back and say, okay, now write it as a test or something like that.
So what would you like me to do, Janco? Do you want me to make a comment?
So your concern was that we're not actually using the supplied parameter, right?
Yeah.
So can we write a test that would actually do that?
actually write a test. So I look at the other steps and I say it's going to drive us to that point. So I'm not too concerned about that, but maybe we make the note. Just when we're going through, do we want to keep this in mind? Going on. Okay, so let's move on to the second one.
So I think that would actually satisfy that.
Yeah.
One.
So are we happy that that would satisfy us?
Annotation.
And let's just go. And we'll do the number one. Yeah, thank you for that. Result. Something like that.
Yeah.
Are we happy with that as a test? Any?
Does it say what type it has to be? Does it just say that it returns the same thing?
So is that important to us?
Yes, I think so.
Single number returns number. So that's actually a good point here. So this is something that and something that helped me when I started out with TDD. I'm actually not happy with this name of this test right now. If I look at the implementation of the test, it's actually number one text returns one integer or something like that. It's a very, very specific case. And one of the things that I've been doing a lot with my tests is when I want to start out, I make it very specific. And then in the refactoring, I try and identify what's the abstraction in this test I can get. So I'm going to leave this like that. That name reflects maybe what we're testing a little more. Are we happy with that?
So can we just go to the next line? I just want to see what it was asking for.
Next line.
The line where you, of the concept, is it asking for something? Okay.
Okay, so we're busy dealing with this, that case there. Add, when you call add with one in it, it should return the number one. And okay, so if we run that test, we're back into the red phase, it's not passing. So now what do we do? What's the simplest step that we do to get this test to pass?
While keeping the other one passing.
While keeping the other one passing.
Pause the string, cast it.
Cast it.
Pause it.
Pause it.
If none is equals to empty, return 0 else 1.
Okay, I'm hearing various ones. So if statement, pass the string, other options. If statement, what if we did this? And I'm going to be a little facetious on it. How about that? Okay, test is passing.
Who doesn't like that? Why?
Okay? So it could feel like it's almost too small a step. And that's important. Like you want to get the steps to be the right size. Like how do you know what the right size step is?
So again, if we refer back to Dreyfus model, if you're in the very beginning when you were taking on a new skill, it's like if anyone's into martial arts, it literally is, and that's why these things are called code katas. It is like a kata. It's not about just practicing whatever. They say practice makes perfect, and that's actually a lie. perfect practice makes perfect. So this is about getting the small steps right and getting into the rhythm and getting into that flow of doing these things. And after a while, these things become internalized and you don't think about it that much anymore. And also, you'll get to a point where you know, oh wait, I've done this 100 times before, I don't need to do this. This is too small of a step. You don't always want to be going in first gear necessarily. So this is going first gear all the way,
Yeah,
and intentionally so.
This is like painfully small baby steps. And it's like the group.
So I just want to ask you, like, in terms of like coding standards and stuff like that, I'm not sure, but shouldn't you always code with your sort of curly brackets with your statements, and isn't that sort of a
Always code with your curly brackets
yeah,
and
your
statements.
statements? I mean,
So the style discussion will be happening in the bar afterwards.
Yeah. So there's some really great talks that you can
Yeah.
see where people will argue till they're blue in the face.
you'll nearly get a green.
We'll
I
talk
guess-
tonight.
I guess
We'll
what I'm-
talk tonight.
Okay, I guess what I'm saying is, even if you're writing these basic tests, whatever your style is, you should stick to it. Don't
Yeah.
sloppy.
Okay. So we've written the next
Not that
test.
you are.
I do get sloppy sometimes. So we've written the next test. It's passing. There's one argument. This is a really, really small step. And is there value in it? And this is where I say, like, you need to be pragmatic. Like, what is valuable for one person might not be valuable for the next person. But I like it. So we're going to make it really, really small here and kind of go through what our brain hopefully is doing while we're writing these things. The bigger steps you make, the more open you are to introducing some unexpected behavior. That's all you're going to be aware of in my mind. So, should we do the refactoring stage? What are we going to do here first of all? Is there any refactoring you want to do? Do you want... Okay.
Thanks.
Is that better?
Just go into the bracket and show what your sharp shows inside.
So you want to see what Resharp is suggesting there. So, how's that for
Yeah, it's also
So
better?
Isn't that the laziest thing in the world to do?
So I'm going in baby steps. I really want it to be
yeah.
very, very simple. Are we happy with this test? Shall we write the next most useful test? Yeah. Okay. And here they've given us another example, add 3 returns 3. So we've been playing devil's advocate because here we've got number 1 text returns 1 as an integer, which isn't a great name anyhow. I could go and write another test, so I could do something like this. And I could change that to 3 returns 3. And then change the implementation there. But for me, I'm seeing a pattern here. And in fact, because they've shown that almost rule as a pattern and put these 2 test cases together, a single number returns that number, it makes this pattern really, really clear. So I'm just going to jump to that pattern and illustrate in the test.
So I'm actually going to jump in and say that's duplication.
Okay.
So, and it's maybe something we can, when we do the refactor stage, do. So that's perfectly valid test, right?
So you wanting to run this test?
Yeah.
You happy with that? Okay.
Go on, there you put Nelson.
No. Let's just do.
Just make it green and then refactor. It seems like we...
So would that work? Okay. And then let's go to the refactoring stage. So our tests are passing. Let's go refactor. So the first thing.
I would change it and use try pause and you get rid of all the statements at the top.
So I would like to get into a bit of a discussion, if I may.
Go ahead.
So we talk about refactoring and refactoring. What does that mean? Anyone want to tell me what refactoring is? What does it mean? No, we've all done refactoring. What is it?
Clean up.
Cleanup. What does it mean?
More readable.
Make it simple as possible, more readable. What else?
Increasing the stability of the code without affecting the behavior.
Yes, so that's important. Don't change the behavior of the code. So refactoring is not an excuse to quickly go and add code to make it do something else while you restructuring and reformatting and all of that. So I find it useful to look out for two things during refactoring. And you can get quite a distance with only these two things. So something we haven't spoken of until now are the 4 rules of simple design. So if you've been in Martin's session earlier, you've heard the term solid mentioned. Maybe you know what it is, maybe you don't. It's very technical for how you should be structuring object-oriented code. So I find the 4 rules of simple design can actually get you a long way. So the first thing, passes all tests. We're doing that, right? So this is a TDD workshop. We're not, we don't even need to spend time on that one, right? So we'll maybe get to 4, maybe not. They are kind of in priority order. So refactoring, if you think of refactoring in terms of rules number 2 and 3, that's refactoring. So 1 is to remove duplication. And duplication can take interesting forms, and it's not always obvious necessarily, and it takes some practice to spot all of those. Right? But that's 1. It's also called the dry principle. Who's heard of the dry principle? Don't repeat yourself. That's what it is. So remove duplication and maximize clarity. So you said, well, a couple of people mentioned, clear intent. So make it explicit. What is this thing doing? So if I read that test name, it says number 3 text returns 3 integer. Well, it's Mark's English, but at least I have an idea of what it means. So it's telling me what the intent is of this code.